With pre-stack gathers in hand, let's investigate the amplitude variation for an event through the gathers. We have carefully interpreted a structural horizon on one of the stacks. Using that as a starting point, we'll auto-pick the event across the gather and create a 4D horizon that tracks the event perfectly. In this section, I have a stack showing the horizon interpreted on this interesting event. You can see the event of the same horizon in the map above. Here are my muted gathers in the gather view. That green dot on the left of each gather corresponds to the same stack horizon. Because it doesn't have offset domain values, it's displayed at 0 offset. I'll zoom in to see the event more clearly. When I turn on the amplitude graph, I see values for a fixed time slice. This would give us a good idea of the AVO if the gathers were flat and had no structural variation. This graph is useful for the first gather, but provides less information in the later gathers as the time of the event changes. To accurately measure the amplitude, I need to track the event. Insight's Horizon Propagator is perfect for this. We can use the stack horizon as a starting point. Let's look more closely at the area around the southern wells. Create a new horizon and enter a name. Because we're picking offset gathers, I will set the gather type to offset. If you're interpreting angle gathers, choose that domain instead. Select the new horizon and change the color and visibility as required. Display the horizon in the map view. Change the picking mode to Propagator. Select the muted gather volume. Select the stack horizon as a seed. Set the search window and threshold. The defaults usually work great, but you can adjust them depending on your data and the type of event. Blocking at faults and constraining an area with polygons will make the process faster and prevent the horizon from jumping events. Click Propagate to see Insight update the horizon as it follows the event through the gathers. The propagator doesn't simply pick the event across each gather. Instead, it follows the path of highest correlation, tracking across offsets and also jumping between inlines or crosslines if there's a pick with a better match. This guarantees the best possible result in all situations. Once the propagation has completed, we see the result as a dashed line on the gathers. These are great. Click to add them to the horizon. The newly propagated horizon color range is set by the class values. Adjust the min-max range to see more detail. The amplitude plot now displays an amplitude profile from this new gather horizon. The results are clearly much better than the original time slice amplitude. If all is well, you can clean up the horizon using interpolation or smoothing. To see how the horizon varies with offset spatially, try rolling the mouse wheel over the offset field in the map view. The horizon updates to show the time values at each offset. If we change the horizon property to amplitude and roll the mouse again, we can get a picture of the amplitude as it varies spatially. Is that a Class 3 AVA I see brightening up? Now this is looking really interesting. I've got some investigation to do. If you have questions or would like to discover more, then visit our website at www.dug.com. And remember, have fun with Insight.